Hello friends, in today's question, a particle is suspended vertically from a point O by an inextensible massless string of length L. A vertical line AB at a distance L by 8 from O as shown in figure. The object is given a horizontal velocity U. At some point its motion ceases to be circular and eventually the object passes through the line AB. At the instant of crossing AB, its velocity is horizontal, find U. So this is a basic figure. So we have a particle which is suspended with a string whose length is L and it is given horizontal velocity U, and this is line AB which is at a distance L by 8 from this horizontal string when this string is vertical. So let us draw the figure according to the question. So we have a point O through which this particle is hanged, and this particle is given a horizontal velocity U, and suppose this is the horizontal line AB which is at a distance of L by 8. So it says that at some point its motion ceases to be circular and eventually the object passes through the line AB. So it means before it crosses, the particle crosses the line AB, its motion is circular. Okay. So let us suppose this is the circular path it is taking, and we assume that at this point, let us suppose this point is Q. Up till this point, the motion of this particle is circular. So now this will be the position of the particle, and like this, and we say now the string, suppose, is making an angle of theta, and at point Q this motion ceases to be circular. Now after this point this particle is going to behave something like a projectile, and it will be traveling like this. Suppose this is the highest point, because it says that the instant it crosses the AB, its velocity is horizontal. It means this is the highest point of the particle. Okay, so it will be doing something like this. And let us suppose here it is having a velocity of V. So this will be length over L, and it is making angle of phi. This angle will be theta, and we can say this length will be L cos of theta. So we can say that this length will be equal to L cos theta minus L by 8. So we get this as L cos of theta minus L by 8. Also we can say this length will be coming as L sin of theta. So these are some of the things which we are going to write initially. Okay. So let us say that suppose this is point O. Suppose at point Q, circular motion cease to exist. So as the circular motion cease to exist, we can say that at this point the string is going to collapse. That is, the string tension in the string will be equal to 0. Tension T in the string becomes 0, and beyond this point particle behaves like a projectile, and from here we can say projectile, suppose projectile, and let its velocity is equal to v. Okay, and making angle of phi with horizontal. So this is the angle phi. So at point Q, this particle is going to behave like a projectile, making an angle phi with the horizontal. Now it is also given that at the instant the particle crosses line AB, its velocity becomes horizontal. So we can say that this is the point Q and this is line AB. So at this particular point, let us call this point as S, and this point is Q, and this is the maximum height H, with the initial velocity V, and this is line AB, and it is a making angle of phi with the horizontal. So it means at the instant the particle crosses the line AB, its velocity becomes horizontal. So from here we can say that, let us suppose this is Q prime, that is Q prime is the highest point highest point of the particle, and from here we can say that its height will be maximum, and secondly we can also say that SQ will be equal to half of the range. SQ will be half of the range, so we already know the formula for the range, which we can put it here. So this will equal to half velocity is v square sine of 2 phi divided by g, and we already know that phi is equal to 90 minus theta. We substitute the value. From here we can say SQ is equal to half v square sine of 2 90 minus theta divided by g, or and this is our point S. So we already know that this SQ is equal to L cos theta minus L by 8. So we can say but SQ is equal to L cos of theta minus L by 8. So it means this is SQ, and this we already found out is L cos of theta minus L by 8. So we can equate these two equations, and we can say, taking L as common, so we get cos of theta minus 1 by 8 is equal to v square sine of 2 theta divided by 2g, and let us call this as equation number 1. And also we can say this is our point O, and string is, this is point Q. So at this point we are going to have mg in the downward direction, and this angle is theta, so we are going to have this as mg sine of theta. We are going to have tension and a force mv square upon L, because L is the length of the string. Therefore we can write this equation as T plus mg sine theta is equal to mv square upon L, but we already know that at point Q tension T is equal to 0. You can say but at Q T is equal to 0. So putting this, we get mg sine of theta is equal to mv square upon L. Here m and m cancels out, so we can say our v square L is equal to g sine of theta. Let us call this as equation number 2. So using equation 1 and 2, so we are going to use equation 1 and 2 and use the value of v square by g from equation 2 and solve it further. So you can say using equation 1 and 2, you can say that L by 2 sine of 2 theta multiplied by sine of theta is equal to L cos of theta minus 1 by 8. So L and L cancel out. So we can expand this equation as 2 sine theta cos theta multiplied by sine of theta is equal to cos theta minus 1 by 8 and divided by 2. This 2 and 2 cancels out. This comes as sine square theta into cos of theta is equal to cos theta minus 1 by 8. Sine square theta, we can write it as 1 minus cos square theta. So we can say 1 minus cos square theta multiplied by cos theta is equal to cos theta minus 1 by 8. And we can just open the bracket. This will be coming as cos theta minus cos cube theta is equal to cos theta minus 1 by 8. Cos theta cancels out. From here we get cos cube theta is equal to 1 by 8, or we can say that our cos theta is equal to 1 by 2. From here we can say that our theta is equal to 60 degree. And we can also say that from here this distance is L. So total distance traveled by, rather we can say total vertical distance traveled by this particle will be L sine theta plus L. So you can say that at the highest point, which is called as Q prime, at the highest point Q prime, the total vertical distance traveled by particle, let us call that is equal to S. So we can say that our S will be equal to L plus L sine of theta. So we can use the equation, kinematics equation, using equation of kinematics, v square is equal to u square minus 2gs, okay, and rather it is plus v square, here g is equal to minus of g, and as we already know, so we substitute the value, we get this as v square is equal to u square minus 2g, this becomes L 1 plus sine of theta, and we already know value of theta, so we can write this as u square minus 2gl 1 plus sine of 60. Sine 60 is square root of 3/2, so we can say v square is equal to u square minus 2gl 1 plus root 3/2. And we already also know that from equation 1, we already know value of v square. From here we can find out value of v square. Okay. So you can say using equation 1, we get this as gl sine of theta plus 2gl and plus 2gl, and this will be root 3/2 is equal to u square. And this 2 and 2 cancels out, we get gl sine 60 plus 2gl plus root 3 gl is equal to u square. And finally, we can say that we can write this as taking gl common. We get this as sine 60 is root 3/2 plus this will be 2 and plus root 3 is equal to u square, or we can say our initial velocity u will be equal to gl, and this comes as 2, this will be 3 root 3 divided by 2 plus 2, its square root. So this is the what we are supposed to find out. We are supposed to find out the initial velocity v with which it is projected with the horizontal velocity. This is the velocity u with which particle is projected horizontally. So this completes the question. Thank you.